Hello guys, welcome back to SGRV-TECH class. So this is my lecture 7 part 2. Okay, so in lecture 7 part 1 we will discuss about whether the special linear is group or not. Okay, so here in this video we will discuss about this integer modulo n, which is nothing but what? Zn. So now we have to show that Zn is a group with respect to addition modulo n. Okay, so what is our binary operation here? So our operation is what here? Addition. So let me solve this question. Okay, so first we have to write the given set. So what is that? That is nothing but Zn. So Zn means what? So this is nothing but integer modulo n, and this Zn contains 0, 1, 2, 3, so on up to n minus 1 element. Yes or no? Yes, of course. So we have seen this in my previous lectures only. Okay, so if you still didn't watch my all lecture 6, first go and watch those all videos, guys. Okay, so now this is my site, which is nothing but integer modulo n. Okay, so now we have to check whether this is a group or not with respect to addition modulo n. Okay, so for checking a group, how many laws should be satisfied? So if it is a group, then here 4 laws should be satisfied. So these all are nothing but a closure law, associative law, and identity law, and inverse law. Okay, so I am going to check here my first law, which is nothing but what? Closure law. Okay, so for checking a closure law, I need 2 elements. Okay, so I am going to take A, and that A is also belongs to what? Zn, and B is also belongs to what? Zn. Okay, and then if one element is belong to Zn and another element is belongs to Zn, then addition of these two is automatically belongs to what? My given set. So it means what? Now closure law is satisfied. So as well as, so next one is what? Which is a associative law. Okay, so next one is what? Associative law. So for associative law, what is our condition? A plus B plus C, which is equal to A plus B plus C. Okay, for all A comma B comma C is also belongs to what? Zn. Okay, so just look at here, guys. If A belongs to Zn and B is also belongs to Zn and C is also belongs to Zn, means the sum of all these 3 elements is automatically belongs to what? Zn. Yes or no? Yes, of course. Therefore here associative law is also what? Satisfied. Associative law is also what? Satisfied. Okay, my second law is also get satisfied here. So what is the third law, which is nothing but what? Identity law. Okay, so we know that what is the identity element with respect to addition? So that is nothing but what? 0. Of course 0 is belongs to Zn, right? Such that A plus E, what is our E here? Which is a 0, and 0 plus A gives me what? A, and this A is also belongs to what? Zn. Okay, then 0 is what? So here 0 is the identity of this Zn. Okay, so 0 is the identity of this Zn. So here identity element is also what? Satisfied. And what is my fourth law? So which is nothing but inverse law. Okay, so let's take one element which should be belongs to Zn. Then there exists and then such that what we know? Yeah, of course. Then there exists a n minus a belongs to Zn. Okay, such that A plus n minus A, which is equal to what? Which is nothing but, which gives me what? N. So which is nothing but what? 0. Okay, there exists a n minus A, because I take my element as A here, right? Therefore n minus A, there exists a Zn, such that A plus n minus A, which is equal to 0. Then A inverse is nothing but what? N minus A. So this is very important, guys. Okay, so this is what, if they ask for finding the inverse of any element in Zn, so if you keep remembering this thing, then you can easily find out your inverse element. Okay, so just look at here, why I have take here n minus 1 means I consider this n minus 1 as my inverse. Okay, so this is what here my operation is addition. Therefore A plus A inverse gives me identity element, that is nothing but what? 0. Okay, so if I take here n minus 1, therefore A and minus A will get cancelled, the remaining is what? N. So that is nothing but what? 0. It means here identity element is a 0. Okay, so this is what, now we can easily say that Zn is a group with respect to addition modulo n. Okay, in the question if they ask directly for finding the inverse of any number, then you have to just so I am going to give you here example. If they give you 6, okay, if they gave you 6 and Z6 contains 0, 1, 2, 3, 4 and 5 here. Okay, is this visible? Yeah, of course. So if they ask to you find the inverse of 3, okay, if they ask for finding the inverse of 3, then directly you can put this form in this formula. What is your n? This is nothing but 6. What is your a here? This is a 3. It means what? 3. In 3 inverse is nothing but what? 3. Okay, so 3 inverse is what? Which is nothing but a 3. Okay, if they asked for finding the 0 inverse, 6 minus 0, which is nothing but what? 6. Okay, if they asked for finding the inverse of 4, 6 minus 4, which is nothing but what? 2. Inverse of 4 is what? 2. And what is the inverse of 2? 6 minus 2, which is nothing but 4. Okay, what is the inverse of 5, which is nothing but 6 minus 5, which is nothing but 1. What is the inverse of 1? 6 minus 1, which is a 5. Okay, so if you keep remembering this thing, then easily you can solve like this type of examples in your examination. Okay, I hope you will get this example. If you get any doubt, please let me know. Okay, let us move on to another example. My second question in this video, find the inverse of each element of Z8 with respect to addition operation. So here they are asking for finding the inverse of each element in Z8. Okay, so what is Z8? So Z8, which is nothing but what? Z modulo n. Okay, so Z8, so the set containing 0, 1, 2, 3, 4, 5, 6, 7. Okay, so Z8 containing these all element. Now we have to find the inverse of each element. Okay, so let us find by using the previous example trick. Okay, so here first I am going to start from 0. Okay, so 0, this element belongs to Z8. Okay, then what is the 0 inverse? So 0 inverse, which is nothing but just to in the previous example I told you one formula for finding the inverse. So what is that? A inverse is equal to n minus A. Okay, so this n is what here? 8. It means 8 minus 0, which is nothing but what? 8. Okay, so now 0 inverse is 8. Next one is what? 1. 1 belongs to Z8. So 1 inverse. So what is 1 inverse? 8 minus 1, which is nothing but what? 7. So 1 inverse is 7. So next element is 2. 2 belongs to Z8. Okay, so 2 inverse is what? 8 minus 2, which is nothing but 6. So next element is 3. 3 belongs to Z8. Therefore 3 inverse is what? 8 minus 3, which is nothing but 5. Okay, so it is next element 4. So 4 belongs to Z8 and inverse of this 4 is 8 minus 4, which is nothing but 4. And what is my next element, which is a 5. What is 5 inverse, which is nothing but 8 minus 5 gives me 3. Inverse of 5 is what? 3. And what is the next element? 6. 6 belongs to Z8. Therefore, inverse of 6 is what? 8 minus 6, which is a 2. Okay. So next 7. 7 belongs to Z8 and inverse of this 7 is what? 8 minus 7, which is nothing but what? 1. Okay. So now we find the inverse of this all element. Guys, you just observe here. We get these all are our elements, and if you observe it, just look at here. So 0 inverse is 8. Okay. So 1 inverse is what? 7. And what is the 7 inverse, which is nothing but 1. Okay. 2 inverse is what? 6. What is the 6 inverse, which is a 2. And 4 inverse is 4. And 3 inverse is what? Which is a 5. And 5 inverse gives you 3. Okay. So here you will get inverse. So yes, you look at here. So you will get here the inverse. These all inverses also belongs to what? This